So welcome back. So in the previous videos we have been discussed about the simple harmonic motion and uniform acceleration and retardation motion. So these are both in the simple acceleration, simple harmonic motion and uniform acceleration motion. So used to draw the cycloidal, used to draw the displacement diagram. So based on that we can able to find out the velocity and acceleration. So in this we are going to discuss about, in this video we are going to discuss about the cycloidal motion. So cycloidal motion is also one of the type of a motion where it can able to produce the cam profile. So in this also, by using this method we can able to produce the, or we can able to draw the displacement diagram, and we can able to find out the maximum velocity and an acceleration. So as you know, this is also one of the type of method in order to find the displacement or velocity by using the cycloidal motion. See, this type of simple harmonic, uniform and a cycloidal depends upon the application where we are going to use in order to find out that particular velocity or an acceleration during that particular condition, or during based on the follower. We are going to identify this type of displacement diagram has been required for an to find the velocity or an acceleration. So based on that only we're going to select whether it might be in a cycloidal motion, or whether it might be in a simple harmonic motion, or whether it might be a uniform acceleration or uniform retardation motion. So based on this only we're going to based on the application or where we need to exactly find, based on that we're going to select the different types of motion. SHM we call it UARM and cycloidal motion. These are the majorly used three motions. So now we'll see about the cycloidal motion. Yes. So displacement, velocity and acceleration diagrams when the follower moves with a cycloidal motion. So the displacement, velocity and acceleration diagrams when the follower is moving with a cycloidal motion. Cycloidal motion is nothing but where it moves in the cyclic process. As you know that how the cyclic process takes, similarly that even the cycloidal motion also will moves in that particular form. So initially again, how we can able to construct from this to beginning is based on the stroke length. For example, based on the stroke length, if I'm taking in the SHM, we used to draw the semicircle, then we used to bisect the equal parts and we used to extend the lines. Similarly, in the UARM, that is uniform velocity and acceleration method, we used to draw the line of the stroke length, we extend the lines, and by taking the center part of that line, and we used to bisect the number of equal parts, then we used to join and we used to draw the curve. But in the cycloidal motion, the process is some little bit different comparing with that both the simple harmonic motion and UARM, that is uniform acceleration and retardation motion. So here first step is, so initially we used to draw the, stroke length, that is what the stroke length is given. So this circle, how we can able to draw the circle is, so the cycloidal motion circle, the dimension will be given in the data itself only. By that cycloidal motion, that is S will be equal to pi by n. So based on that n, we can able to find out the S. S is nothing but stroke length will be given. So based on that data, we can able to get the circle dimensions. So now first step is, so just I'm going to draw the line of the stroke length assuming 40. So just I'm going to extend the lines. Just extending the line. So once what happens, extending line, now this will be the starting point. Now I'm going to draw the circle based on the given dimensions. So now taking this point A as in a center, I'm going to draw the circle. Now A will be the one part, and by drawing this you can see the A dash and B dash. By drawing these equal lines, see, by just drawing both the endless lines and joining equally from the center, so we'll form another two parts. We can able to see this and this. Now what we are going to do is, just I'm going to draw the circle now. So next step, what is the next step is, so angular displacement. So the rise, what they have given the rise, similarly it has to fall, right? Rise, dwell and the return. Rise is nothing but where the return stroke, intake stroke, that is inlet stroke, and the dwell is in the rest position, and the return stroke, that is the return outer stroke. So now, so based on this given length, again we are going to divide the equal parts. So here we have taken as in a 6 equal parts. So assuming this as in a 120 degree means 6 equal parts, so each will be having a 2 centimeter. By taking as an 20 degree as in a 1 centimeter, 20 degree will be equal to 1 centimeter. So based on that we're going to divide the number of equal parts. So number of equal parts now we have been divided with the 6 equal parts, 1 2 3 4 5, and you can able to see these 6 equal parts. So each will be having the, as per the scale, either you can take 10 degree or at 15 degree or at 20 degree. Now for example, by assuming that we have been considered as an 20 degree will be equal to 1 centimeter, right? So 120 degree means 6 centimeters. So now we have taken as 6 equal parts. Now I have been drawn 1 2 3 4 5 and 6. So this is 6. Now already we have any 3 points by making this equal position. So I'm just going to draw from this point by keeping this straight line. By taking the scale, just going to draw one line to joining to this point. So I'll repeat once again. So from the center point, by taking this exactly straight line, I'm going to draw to this B. One line I've drawn. Now one more we have in a B dash and A dash point. Now we can able to see this B dash by taking the by drawing the line parallel to this A. By drawing the line parallel to this A, I'm just going to draw the line which will be joining to the E. And similarly, which is having a dash point, which is I'm going to just draw the parallel line to this up to parallel line which will be there. I'm going to draw till B, right? So here now 6 parts are there, right? So here initially 1 point and 2 will be joined from here, and the remaining center will be joined at the point in the center line, and remaining 2 will be joined here. So now I've drawn the 3 lines. So from one A dash and B dash, by taking the B dash as the line to A dash A parallel, and from A to A dash we have drawn a line to the parallel line. Now the next step is what I'm going to do is, so we have been extended this line first point. Now I'm going to see this, which is the line is bisecting this, means it is intersecting both these lines. Now what I'm going to do is 1 to 1 dash, which is the part which is there, I'm going to bisect there. I'm just going to mark that point, and similarly the line which is passing to the B, where I'm going to mark one more point. So I'm just will mark that point. Now from C, what is there, again this center line has passed to the C, so where I'm going to draw the joining that point. And from the above the axis line which is there, D and D, which is the bisecting or which is moving, that we're going to join, or we're going to mark these points. Now what we're going to do is, so I'm just start joining. So you can able to see this in the free hand, we will draw the curve here. So the next part will be the dual rest. Again the return will be in the same position. Now how the cycloidal means, the cycloidal will move from all these points to this, and it will be in the rest. Again it comes back to the cycloidal motion, or the cycloidal, which will come back to the return state, means it is rising, it will be in the rest, again it comes back to the original position, that is in the form of return stroke, right? So this is how the cycloidal motion will takes place. So based on that we can able to find out well angular velocity and angular acceleration. So the displacement, velocity and acceleration diagram that we have seen, the follower moves with cycloidal motion as shown in the figure. So we know that cycloid is a curve traced by a point on a circle when the circle rolls without slipping on a straight line. See, this circle will be continuously, the circle which is drawn, it will be continuously rolling on all the points without slipping, right? So without slipping on a straight line, that is which are the lines we have been drawn, A and A dash, B dash, where we have been drawn the parallel lines. So similarly in case of cams, this straight line is a stroke of the follower which is translating on the circumference of the circle, that is the length stroke of equal follower, that is stroke length S, what we have been taken as a stroke length S for the follower. So therefore the radius of the rolling circle, with the rolling circle is there, S will be equal to 2 into P. That is by calculating that we're going to get in a dimension. So that dimension, taking as that as a radius, we're going to draw that cycloidal circle, right? So by using these conditions, mainly we can able to draw the displacement diagram. So this is a one of the method where it has been used in order to draw the displacement diagram. So this is about a cycloidal motion. So as we have been discussed, simple harmonic motion, uniform acceleration and retardation motion, and cycloidal motion. So it is also one of the type of motion where it is used in drawn to find out the, or to draw the displacement diagram. Again from based on this displacement diagram, we can able to draw the cam profile to trace the paths which is the follower is following. Here we have been not drawn the any follower. So in the cam profile, by using this data, we will go to construct the cam profile by using this displacement diagram. So this is a procedure how to construct the cycloidal motion. Thank you.